We are studying about units of measurement. What is a unit? Unit is the quantity which is measured as a standard measurement. So a standard measurement of a particular quantity is declared by us as unit of that quantity. Like length is a physical quantity, but when we make that this much length is our standard one length and we give it a name, and that name is 1 meter. Other group of people may say, for me this should be the 1 unit of the length and I will call it 1 foot. So that is his unit. So in this case there may be so many units for any given quantity. For the mass it may be kilogram, it may be pounds, it may be tons, and there are so many things. So how do we fix a unit? What are properties which we see, which we consider when we are fixing a unit? So for fixing a unit it should have 4 particular qualities, and the quality number 1 is that it should be of suitable choice and it should be acceptable to all, it should be easily reproducible, and there are so many other characteristics which we can list out here. So I will write here which are our requirements to fix up a standard unit. How do we choose a standard unit? The qualities, the requirements are seen as mentioned here. Number 1, it should have a suitable size. If we want to have a unit for the mass, what is our daily requirement of mass measurement? Answer, we are buying vegetable every day for our household purpose. Okay, and how much vegetable? We know a quantum of vegetable we need for our household purpose. So we keep the unit as 1 kilogram because that is the required quantum which we need every day. So we do not have to make it in hundreds or fractions. How it will appear if I go to a vegetable vendor and tell her that I want 1 upon 273 ton of vegetable, or if I tell her I want 375 grams or milligrams of vegetable. So this will make things complex and difficult for us. If I ask her to give 1 kg, 2 kg, 5 kg, it is understandable. So I make my kg in such a way that I don't have to multiply it many times or make it a fraction many times. But now, when I am loading coal on my truck, coal on the truck, I cannot use this kilogram because it will be thousands of kilograms on a truck. Then I make a new practical unit, and that unit is ton. So the truck I am sending with the coal is having coal of 5 ton, 7 ton, 10 ton, 15 ton, 20 ton, like that. And I don't have to number it for thousands. So what I have done, I have changed my unit to be suitable, to be of more suitable size. So what is our use? According to that we make the unit. Now if I want to measure, say, size of proton, neutron, which is very very small. How much small? 1 upon 10 to the power 15 times, 15 after 10. That much meter is the size of a proton. So I make a new unit and I call it Fermi. 1 proton is 1 Fermi size, and now it will vary between 1 Fermi, 2 Fermi, 0.5 Fermi, like that. Similarly, we are using different units for gold. You have seen carats. We have different units for pressure and other things. Wherever we need the unit, and we don't have to multiply it with many complex numbers. So that is the suitable size. So for length, we have chosen a size this much, 1 meter or 1 foot. For mass, the daily vegetable we get 1 kilogram. The Britishers choose it, the size of the bread loaf they used to make 1 pound. Similarly, for the time, it depends upon the whatever is our purpose. It may be 1 day if we are counting in days. I cannot ask you, please come to the class after so many seconds, so many thousands of seconds. No, I will ask you come after 1 day, because day is a suitable unit of time for this purpose. So according to our purpose, we change the size, and that is how we make the unit. Then, this should be accurately defined. If I say this is 1 meter, another person will come, he will say this is 1 meter. It is a different length. So, we must accurately define. Similarly, 1 kg, how should we define it accurately? After this class, you will see the definitions of different units we have fixed as matter of international standards. We have defined the units so accurately that there is a very, very seldom chance that there may be a mistake. There is not. So that is how we accurately define it. Then it should not change with time. Today my meter is this much and I put something as 10 meter long. After few years somebody comes and again measure with my scale and it comes to be 10.5 meter. So with the time it should not change. If I have this iron piece saying that it has mass of 1 kg, after 2 years there may be certain rusting or something and it has deteriorated. And now the 1 kg has become lighter. So that has changed with time and physical conditions. It should not happen. Whatever is the measurement done today, that should remain whatever is the time pass. Even if hundreds of years pass, this measurement should not change. Then we have easy access to it. If I say that this is 1 kg, okay, you say this is with you. How do I know which is 1 kg? So I should be able to make many replicas of this 1 kg and all of us should have access to it, so that everybody will measure how much is 1 kg. Similarly, I make a standard 1 meter and then I make many replicas, samples of this 1 meter length, drawing 2 lines on a rod. And that is distributed all over the world. So making replicas, giving it easily, everybody can get it easily from anywhere. That is, we are accessing it, and that accessible, it should be easy. Okay, then we should be able to reproduce it. Suppose we are making a thermometer. I am manufacturing thermometer here, and for that I need a temperature of 0 degree and 100 degree to mark it. So we make a process that I will take ice, put it in the water at the normal pressure, then the temperature of that mixture I will mark at 0 degree. Then I will boil that water, the pressure is normal, and when it's boiling, steam is coming out. At that time I take the thermometer in it, and wherever is the height of mercury or alcohol, whatever it is, there I mark 100 degree. Now this set of experiment is such an easy one that anybody can do in his country, in his home, anywhere he is. That means he can always reproduce 0 degree and 100 degree. You don't need a very specialized and sophisticated lab for that. So our standards should be so easy, which are easily reproducible. Like time. Sunrise today and sunrise tomorrow will have between it, there is a time gap of 24 hours. Yes, there may be a change of few seconds, you can say, but very approximately it gives us 24 hours, and this is easily reproducible. There are different methods for time, for length, for mass, and for all other units where we can produce the conditions which will give us the standard unit. So, it should be easy to reproduce, it should be accessible, it should not change with time, it should not change with conditions, physical conditions, it should be accurately defined, and the size should be workable, suitable, so that we don't have to multiply it with large number or multiply it with fractions. So these conditions you must remember. What are the qualities or requirements to choose a standard unit? And now the next thing we study, how the system of unit was formed. It was formed by the group of people, the group of physicists who use it. Okay, they make their own units. So first a group of people formed it, a city formed it, a country agreed to it, and that system was used for commerce everywhere. For give and take, we were using the system of measurement. We were using it for business, for commerce, and for scientific purpose. So, the development of this measurement system was done differently in different countries. The one very developed system of measurement was developed in Britain, and that system is known as British system. British system. So what we are going to study is systems. Systems of measurement. One is British system, and in this we will discuss three quantities which are the major quantities used in mechanics and from the very olden times, and these quantities were mass, length, time. So in British system, for mass they used the unit pound. For length they used feet or foot. For 1 foot, 1 pound, and for time they choose second. So this is known as FPS system. Then their neighbors, France, developed a French system, and in French system length is measured by centimeter, mass is measured by gram, and time is measured by second. So this we call CGS system, this we call FPS system. Centimeter for the length is a very small unit. Similarly, gram for the mass is a very small unit. For practical purpose, for commercial purpose, we have to take higher units, larger units. So they modified it, and it was modified to, the unit was made as meter, mass was taken in kilogram, and time was again taken as second, and we call it MKS system. The main difference between these two systems was that this system was a metric system. Metric. In metric system, the next higher unit comes by multiplication of 10, or lower unit comes by division of 10. Like if we go from gram to decagram multiplied by 10, 10 grams make next unit decagram, 10 decagram makes next unit hectagram, 10 hectagram makes next unit kilogram. So all the units are simply multiplication of 10 to the power something. That system is known as metric system. So what's a metric system? It is such a system that the next unit, higher or lower, can be calculated by multiplication of 10 or its power. What about the other systems? This FPS system, like this foot. What is the next higher unit? If we don't want to measure this, we want this. So the next unit was yard. Y-A-R-D, yard. And 1 yard is equal to 3 feet. Okay. Then 220 yards used to make 1 furlong. 8 furlong or 1760 yards used to make 1 mile. So what are the higher units from foot? Yard, mile. And multiplication factor 3 and 1760. So this number has to be remembered whenever we want a conversion. And it is a more difficult process than remembering this conversion, where higher units are achieved, are calculated by multiplication of 10 only. So this was easier. So this is the benefit in metric system. So you must remember what is the drawback of FPS system and what is the convenience in metric system. But again, with the advent of time, there was development all over the countries in the world, and new phenomena were introduced. New fundamental quantities were introduced. Like we had a quantity temperature, the degree of hotness. We had a quantity that was electric current. We had a quantity that is luminosity of a light bulb. So these quantities also have to be measured, and these cannot be measured in only these three: length, mass and time system. So we had to change our system. Okay. Then there were two basic phenomena in our world which made it compulsory that we should have a uniform system all over the world. We should have a uniform system of measurement all over the world. What made it necessary? Why? The two things. Number one is our aeroplane system. We used to go from one country to the other country to the other country in matter of hours. So there was intercontinental travel, plus there was intercontinental business. And when I am buying something from the other, I must be conversant with the units they are using, and they should be conversant with the units I am using. मैं किसी से ये नहीं कह सकता कि आप मुझे पेट्रोल दीजिए और वो मुझे बोलता है कि $20 पर गैलन मिलेगा, और मुझे नहीं मालूम है कि वो सस्ता है या महंगा है. क्यों? क्योंकि यहाँ पर वो बिकता है 60 rupees per liter. You cannot compare the two unless we know that how much are the liters in 1 gallon. इसलिए ये बहुत ज़रूरी था कि system of units should be uniform all over the world. So, for the purpose of our business, for the purpose of our commerce, it is necessary that we need the unit. We have the units which are uniform. For the pilots who are doing intercontinental journeys, travel, they must be conversant with the same system of units everywhere. So that was necessity. And later this necessity increased in many walks of life. So it was decided that we should overhaul our system of units. And a body was made. There was a body in which physicists of all the countries sit together and they decided what should be the units, how the things should be measured. They had their headquarters near France, near Paris. There is a place, Geneva. There they are having it, and it is known as International Conference on Weights and Measures. International Conference on Weights and Measure. They are deciding the measurements. So this international body, which is known as General Conference on Weights and Measures, they decide for all the nations in the world that what should be our general units, and the information is given to all the countries. That is how the measurements of different physical quantities are uniform all over the countries. Okay. Now, this system is followed by all the world through over internationally. Therefore, it was given the name System the International. System the International, or we briefed it SI system. So we developed, this was done around 1971, the conference was held, and this system was adopted, and this took over the system of that FPS system, CGS system, MKS system, and so many other systems. It was agreed that all the inter-country transactions, and for all those matters where different countries are involved, we will go for SI system. Now, in the SI system, all the quantities were included, which we have done in the previous class. There were 7 plus 2, 9 fundamental quantities, which were taken as fundamental quantities in SI system, and you have seen the units which we have written in the chart over there. So, this is System International. Now, what was advantage in this? Whatever were the good points of all the systems were included in this system, and this system was basically taken from MKS system. MKS system is that meter, kilogram and second system. That because it had an advantage that it is a metric system. So SI system is also a metric system, right? This is one advantage. The other advantage is that this system is a coherent. We can underline the benefits of this system. So this is metric system, rationalized system and coherent system. Metric is one, that means the next higher unit can be achieved by multiplication of 10 or division of 10 for lower unit. So we developed a system for that. Okay, and we will study that. how we multiply by 10 and change the nomenclature. Then it is a rationalized system. Rational, reason. Okay, in earlier system, there were different forms of energies, and for all different forms, we may have different nomenclature of the unit. Like, if we are using energy in the heat form, then we will say the unit of heat energy is 1 calorie. Calorie. Okay, but when we are doing the work and converting it to kinetic energy, potential energy, that is mechanical energy, we used to calculate this energy as joule. The unit of that energy was joule. When we are taking electricity at home and running it for a few hours, the billing is done by making a unit of electrical energy, and that unit is kilowatt hour. So kilowatt hour, joule, calorie, all these are the units of energy. But basically in physics, energy is energy. The capacity to do the work or the collection of work done is energy. So if it is only one physical quantity, why there should be 3 units of it? Why we should bother? Why we should make it complicated every time examining that which type of unit should I use? I don't want to examine that. So SI system says, okay, for all types of energy, we will use only one unit, and that unit will be joule. So in SI system, we have made the unit joule. अलग अलग सिस्टम में अलग अलग एनर्जी होती, एनर्जी का नाम हमने अलग अलग रखा. हीट में कैलोरी, मैकेनिक्स में जूल, इलेक्ट्रिसिटी में किलोवाट आवर, पर हैं तो तीनों एनर्जी, तीनों ही वर्क डन है. तो अलग अलग नाम क्यों होना चाहिए? लॉजिक यही कहता है, रैशनलिज्म यही कहता है, ये रैशनलाइज्ड, लॉजिकल. तो लॉजिक हमारी यही कहती है कि एक ही फिजिकल क्वांटिटी है, एक ही नाम होना चाहिए. सो वी मेड द नेम जूल. दिस इज रैशनलाइजेशन in SI system. Other thing is coherent. Coherent is we made the unit in such a way that the higher units are only multiplied with multiplication of 10 or the other numbers. For any conversion, we do not have to remember any number. Once again, coherent means if we make any derived unit from fundamental units, we do not have to multiply with a given numbers. Like we make force, which is mass multiplied by acceleration. 1 unit of mass, 1 unit of acceleration will make how many units of force? 1 unit of force. This is property of coherency. So again, what is pressure? Force upon area. 1 unit of force divided by 1 unit of area. That is, Newton divided by 1 meter square will give the unit of pressure, that is Pascal. But how many pascals? 1 Pascal. So we don't have to remember numbers anywhere when we are converting. We are going from fundamental units to derived units. So unit of fundamentals will make unit of derived unit. This property is known as coherent property. So these are the 3 basic qualities of SI system, and that is why we favor SI system. We can say these are the advantages. Advantages of SI system. Okay, and so this is SI system, which was started by General Accountants of Weights and Measurements. Okay, but in our country, do we have an authority who looks after this system? Yes, we do have, and that authority is National Physical Laboratory. NPL, this is the authority which looks after weights and measurement in India, in our country, and from time to time there are so many other regulatory authorities as appointed by government which looks after weights and measurements and how these are being applied in our country. So this is SI system. Now we can write two lines, what is meant by rationalized system and what is meant by coherent system. Okay. Okay, so here you can see rationalized system is what? Only one unit for a particular physical quantity. Like for energy, there will be only one unit, joule. It will not be calorie, joule or kWh. These will not be taken as a different units. Okay, then what is coherent property of SI system? This property says that one units of fundamental quantities make 1 unit of derived quantity. No complex numbers are involved in it. This is a simple and coherent system. So it's a metric system, it's a rationalized system, it is a coherent system. That is why we adopt SI system, and that is international system. And in this we have defined the units of all the different quantities as we learnt in the previous lecture.